Welcome everyone to this joint webinar hosted by Axiad and our partner Atos Origin. Today's topic will look at digital identity to secure network, machine and data. One of the things we're seeing in today is that there is a lot of focus on enabling or protecting access from end users using MFA across the board, moving to a passwordless world. And this is something that has seen a lot of progress over the past few years. But what's a bit newer, and we see increased interest as well and increased risk, is looking at trusting the identity of the systems, application, and devices that also are part of our ecosystem. Next slide, please. So today for this, so let's go quickly through an intro. So my name is Jerome Becker. I'm Chief Operating Officer for Axiad, based in Santa Clara, California. I've been in the industry for over 25 years in identity and access management, and in the US for 20 years, despite this strong accent, which I apologize for, but I can't really get rid of it. But next, with me, I've got a couple of colleagues from Atos Origin. Vieri?
Good morning, my name is Vieri Tenuta, and I'm a cybersecurity products offerings manager with Atos. I'm also part of the Atos expert community, and I've been working in security and security-related functions for information technology and operational technology for the past 16 years.
Axel?
Yes, good morning, everyone. Axel Santos speaking. I'm in charge of the business development for IoT security and PKI security.
Great. Thanks, Axel. Before we get started, a few housekeeping rules. First thing is, so this webinar is being recorded so that it will be made available for people who want to have a look at it. After, the slide also will be made available. You will see our email contact at the end, so feel free to send a request. We're trying to target around 30-35 minutes for the webinar itself so that we have time for questions at the end. I really appreciate if you can stay on mute during the presentation and mute at the question time. And the best way for the question, we'll appreciate if you could put them in the chat window. You can send to everyone, that's okay. And when we reach the Q&A part, we'll go through your questions. And feel free to put your questions there at any time. A quick review of the agenda. So we'll go through a quick intro about who Axiad and Atos are and what's the relationship between the two companies, the partnership. Then we'll talk about PKI, and more specifically PKI in the context of machine authentication. And we'll go through a number of use cases to illustrate the different way PKI can be used to enable trust for a variety of devices and application. And then at the end, as I mentioned, we'll have time for Q&A and discuss next step. So why are we here today? So there's this relatively new term called machine identity management, which Gartner, for example, has been talking about and pushing. And I think what we're seeing, and as I mentioned at the very beginning, user authentication and moving from password to MFA to users is a well-established concept. I think every company out there has already been through that or is going through that. And the question is more how to extend the use of user MFA to everybody in the organization. So this has been around for quite some time, and we see a lot of progress, which is great. But a new area, I think, that at least relatively new, where we see new attacks happening and new threats, is around all of these non-person entities, all of these devices, application systems that are interacting on our enterprise network, that are sending email on behalf of the company, that are accessing information. So here we're seeing that the same issue of trust and making sure that only the right device is connecting, only the right application is sending email to us is as important, if not more important, that for users. And the thing is that there is today much more of this non-person entity on our networks than actual users. And you can see here some of the most recent press releases and activities that are happening there. So it's a real problem. And it's relatively complex, as we'll see when we get in the meat of the presentation, because every application and devices out there tend to speak a different language. So enabling PKI for all of it is complicated. The good news is, as we'll go through the presentation, is we've got some recommendation and some solution for that. Next slide, please. A few words about Axiad. So we are a 10-year-old company located in the Silicon Valley in Santa Clara. We specialize in identity and access management. Our vision is to restore trust in the digital world. Typically, our customers tend to be in regulated industries, large enterprise, governments, healthcare, finance, defense contractors, infrastructure company, and technology company. Moving to the next slide. Our core product is what we call Axiad Cloud, which is really a platform that includes a number of services. And kind of the whole story there is that we're looking at providing trusted identities across the enterprise for all type of users. So whether it's your normal employees or your privileged users, your contractors, your partners, and so on. So for this, you need different level of user authentication. So we support different type of devices with a very user-centric credential management. The other big part of it is this identity for machine and system that we see increasing adoption there. So the core of that part, and actually at the center of everything, because it's important for user authentication, is the PKI offering that is part of our cloud, which is we offer a private PKI that is dedicated to you, or public PKI, which is publicly trusted, so connected to, for example, the US Federal Bridge or Safe Biopharma, and can be trusted by browsers out there. So what's specific about our offering is that it's a virtual private cloud, so it's dedicated to you, protected by an HSM. So where does Atos and Axiad fit together in this story is that the whole PKI technology as part of our offering is based on Atos technology. So everything you will hear from Vieri and Axel going forward is available through Axiad Cloud, or is also available on-prem if you want to do a PKI on-prem implementation. We are also an implementation partner for Atos region in North America. Next slide, please. I'll let Vieri take over.
Yeah, thanks. And so Atos is breaking into the North American market with security with our 5,000 security experts that we have globally. And we support this network via our expert community and what we offer in general, which is not just from the perspective of public key infrastructure and cybersecurity products, but also technological services and technological development and engineering and deployment and management. So we offer quite a lot from IT solutions and services, but also operational technology and other things. We have a pretty significant amount of revenue globally. In 2019, we had $12 billion euro in revenue, which shows our strength in the marketplace with our products and services, but also allows us to form these relationships with partners like we did with Axiad. So I'd like to thank the Axiad team for allowing us to hang out today. So we'll go into the next slide. So what are we talking about here with our public key infrastructure specifically? And as Jerome said, we offer the IDnomic solution for our PKI. And what this entails is a secure, controlled end-to-end solution. So what does that mean exactly? It's an end-to-end solution because it does offer flexible deployment for on-premises hybrid options where it is hybrid and in the cloud or multi-locational. But also it does provide you with an opportunity to use this as PKI as a service if you do not have the resources or you need complementary or augmented services or even management of this infrastructure in general. It's high performance. We have many customers that manage millions and millions of certificates, millions of user identities, millions of device identities. And so because of this, focusing on the speed of our solutions is important, especially in an environment where speed and uptime in production is so important and critical to operations. It's highly secure. Obviously, PKI has been around for many years. And so building on this technology and this knowledge of all of these things is important. But in addition, developing our software, developing our infrastructure and the things that we connect to this software, like hardware security modules and other aspects of the encryption process, that makes it a more secure product in general. Great customer experience. A lot of the time when we talk about PKI or encryption, it's a wheelhouse that many people don't play well in, or they don't have a lot of experience in. And so when I was in college, a lot of the questions that people would ask is like, can you explain encryption to us? And many people can't explain how encryption works, or certificate management, or any of these things when it comes to identity and access management. And that makes it so much more critical today when it comes to ease of use. And so our public key infrastructure and, of course, the Axiad cloud solutions provide customer experience that is easy to get into, even if you don't have extensive experience with this kind of technology. Of course, large support. So when we talk about manufacturing and other types of industries that are moving into more operational technologies and IoT, being connected to traditional IT environments or IT-OT converged environments, we see a widening of the threat landscape when it comes to the number of devices that we're adding to this network. And so traditionally, we've talked about identities of people, but we're talking about identity of devices here. And it can provide many different functions, but we'll get to that in the next slide. And then finally, it's field proven. So the IDnomic solution has been used globally. It has, like I said, millions of certificates that are managed by it globally. And in addition, we have a refined process in order to implement this for our customers. And then finally, we have our investment in new features and innovations, which, because we understand that technology changes consistently, we have been looking towards the future of securing these IT-OT converged environments and making sure that we have solutions that address these challenges that our customers are looking for. Next slide. So what are some high-level use cases? We've talked about all this fancy technology and what it does. Well, what do we use it for? So enterprise security in general, we can manage logical access to IT systems with multi-factor authentication. So what does that mean? We can put certificates on smart cards. We can put certificates on wearable devices. We can put certificates in other types of tokens that can be used for multi-factor authentication. In addition, it can protect the exchange of that sensitive information that's going across the wire, either in digital signatures or email certificates that provide that non-repudiation of those particular emails. And then we can also use certificates for things like point-to-point tunneling and other aspects of encryption. And then finally, secure network infrastructure. So how does that work? We can use it for authentication and authorization to use networks, which only could be applied in a whitelisted environment, which really is more beneficial, as we all know, in a security environment. And being physically segregated is something that we've enjoyed in an operational technology or an IoT environment in the past, which, as we know, this is not something that's consistent anymore and really is going to move into the future where it's more converged, especially with wireless technologies becoming more important. So how do we manage access to those things? And it comes down to authorization through these certificates, because what we can do now is we can validate that that device is who it says it is or what it is, right? In the public sector, PKI can be used for protection on documents that are physical documents, such as passports or identification documents in general. This validation is essentially a digital signature that's stored on this document through an RFID chip or some other mechanism. The management of digital credentials for citizens in the public sector. So how does a country manage the way that they identify their citizens in their country and how they receive services from the government, social services, or get payments or pay their taxes and so on? So these are all methods for a government or really anyone to validate the way that to validate that people are who they say they are. And then, of course, it can enable secure online services. So you're talking about SSL connections and website certificates where you're ensuring that they are who they say they are, and then also you're encrypting that traffic between them. And then finally, in PKI, we're talking about IoT and IT-OT security, which kind of encompasses the things that I just talked about, because it marries all of these concepts together, network authorization and other things. But in addition, it brings a new layer of devices that can be secured, which traditionally have not been because of processing constraints or device size or length of time that they're required to be in the field and so on. So we're going to talk a little bit about some of these protocols that how they play well with all of these things, but in specific, we're going to talk about IoT and OT security and how these protocols help with these types of use cases. Next slide, please. So what is our IDnomic solution? And our IDnomic solution, if you look at this slide, is comprised of our certificate authority system, which sits in the middle. And on the top layer, you'll see users, which is highlighted or blacked out, really, because we're focused more on the machine layer below. And the one that we're familiar with is the user section, because that's where people sit of using smart cards or using tokens or using some kind of solution to authenticate to devices themselves rather than the devices authenticating. It uses things like mobile technologies to be able to authenticate, like single sign-on, or when you press a button on your device because it pings you to say, did you log into this, and so on. So all of these things are secured by certificates, but we're going to focus on this lower layer of machines today. And if you look at the right side where it says infrastructure servers and then moves around to network devices in a counterclockwise fashion, these different types of protocols like SCA, SCEP, EST, CMP, ACME, and AEP are all things that build off of each other as you go from the network layer to something a little bit more sophisticated on the OT side. And so what do all these things mean? And on the bottom, we see IDRA, which is our registration authority. And that plays really well with other types of systems that are able to register devices from a management perspective. But what our PKI does is offer you the opportunity to provide these types of devices on provisioning or during management with these certificates so that they can be secure. Next, please. So what is our certification authority? We talked about it a little bit, but it's a secure centralized management of private certificate authority lifecycles. And that sounds like a fancy term, but what it really is you have to manage that whole lifecycle of that certificate. How is it created? Who is it given to? Do we know that the person that we're giving it to or the device that we're giving to is who's supposed to be receiving it, and so on? How do we manage those things in the event of a breach or something that requires that revocation of those security certificates? And how do we see all of that information when it comes down to management of that? In addition, having that visibility into those certificates is important for functions like auditing and compliance, which typically are not at the forefront of operational type activities. That auditing is often looked afterwards, and then it ends up being findings that we as technologists have to deal with, and usually it's some kind of emergency, right? So to prevent that situation and having that capability to consistently audit and provide lifecycle management of these certificates in a secure manner is what the certification authority does. So it guarantees that integrity and authenticity of the data contained in the certificates because it's a centralized location. It works with either physical HSMs or other encryption vaulting in order to ensure that these certificates are valid as well. And it provides a technical baseline that meets the highest standards in terms of performance and functionality. Like I said, the transactions per second are super important when it comes to IoT, OT, and other things, and of course in your normal IT environment as well, and with your users and so on. But the fact is that I just named 4 things that need to use all of these certificates, and from those 4 things expand into a footprint that could be millions of devices and users. So our system is capable of handling all of those. So what are the key usages of these? Because our IDnomic software is modular, you can use this as a separate entity, or you can use it as a combined system with some of our other components. So we can secure access to business devices with strong authentication. You can give devices like mobile devices or IoT, OT devices, digital certificates in order to authenticate them and ensure that they are authorized to use specific resources on your infrastructure. Securing access to Wi-Fi and VPN corporate networks, either through authorization to that network specifically, but also the tunneling in between the VPN as well as secured through these certificates. And then finally, data protection with encryption and signatures. So how do we prove that a document, when it gets to the other side, is the same as when it was written and it wasn't changed in transit? Or how do we validate that somebody's signature on a document is true? And so all of these things are managed through the certificate authority system. This also supports a zero trust network approach, which is kind of a buzzword today, zero trust, but it's something that we've always been moving towards in security that I've seen, which is inherently in the past we've talked about, the way that we should trust but verify someone. And in reality, that doesn't really make a lot of sense when your adversaries potentially on your infrastructure and outside your infrastructure are unknown, right? And so when the internet was very young and we were able to say that every single person that was using it was a nuclear scientist at the Department of Energy or a trusted professor at a university, we could say, sure, trust but verify. But now, because we've connected literally every part of the globe, this is something that we need to address. And so how do we do that without sacrificing convenience of the user and having them jump through a whole bunch of hoops in order to get to that? It's a process that we have to digitally transform to in many environments, and the certification authority can help with that. Next, please. So the registration authority, it enables complete management of certificates for IoT devices and machines, right? So we talked about what does that mean to register these devices? And so it registers this management, right, through different protocols, EST protocol, CMP protocol, version 2, ACME, SCEP, and more, as you saw on that graph earlier. So how do we do that when it comes to integrating with traditionally non-OT devices like Microsoft Windows devices and so on? Well, it can also offer this seamless integration into these using these other protocols, and as well having capability to connect directly to SOAP API functions. So if you're astute enough to be able to create your own connectors, you can do that with your infrastructure. So what are the key usages of this particular product on its own? It can be distribution and management of digital identities to objects and machines. And that alone is so powerful in today's market because we're all looking to get to that. How do we secure this environment that is traditionally non-connected? And in reality, this solution can help. Next slide, please. So we're going to talk a little bit about the protocols and some of the use cases that are behind these things. And I'll talk about an energy distribution leader in France that Atos provided our solution to. And really their challenge was, how do we distribute a ton of digital certificates using HTTP to all of its network hardware? And they're trying to authorize these network devices to talk to each other and to exist really on this infrastructure in this network. And so the challenge was, how do we manage all of these things while at the same time having visibility into them? And then in addition, how do we provision all of these devices in a quick manner? And so the main benefit to the SCEP connector that was used in this solution was a wide compatibility with network devices on the market. And then in addition, it has part of the protocol, a certificate renewal automation function that allows it to renew these certificates on the lifecycle rather than having a manual interaction to perform that task. So SCEP originally was designed as a protocol to manage these certificates between network devices. And so because of that, it becomes a native option for us to use for that kind of network management. It's very simple to distribute using this because it is something that's built into the protocol. And because of that, our solution can talk directly to this connector. And so the drawbacks are, of course, it's getting old. And as we move on, we realize that there are different methods to doing things. And then, of course, because of the way the technology works, it's very quick. And so there can be other limitations that crop up as time moves on. And so one of those limitations is, of course, with IoT and OT is the processing power, and then, of course, restrictions on any kind of resources on these devices. And in some operational environments, you may know or may not know that these devices could be on batteries, which need to last 15 years. And because these batteries need to last 15 years in a remote environment, any kind of transmission of data back and forth from this reduces the longevity of this battery. And because of that, adding any layers of security could be detrimental to the lifetime of these devices, right? And so one of the hangups on this is the SCEP connector is only able to use RSA encryption keys, which are larger than one of the other protocols that we're going to talk about shortly. But they are larger, which means that when these are transferred back and forth, it can actually degrade the lifetime of these devices. So in response, the industry has built all of these devices to use a new protocol, which we'll talk about in a couple slides, but we'll go on to the next slide. So how do we use these things? The AEP and the SEA connectors. So AEP, or Auto Enrollment Protocol, enables the enrollment of the Windows operating system, PKI. So what it does is essentially take the place of this Windows operating system, PKI, and allows it to talk to objects and the registration authority in a method that is universal. So maybe it's not inherently natively supported, but it can go directly into this. And how do we manage things that potentially are on Linux-based systems? Well, that is the SCEP enrollment agent, or the SEA connector, which is essentially a connector on the operating system for Linux that does the same thing and makes it capable of using this SCEP protocol. So how did this get used in particular? There's a major bank in EMEA that Atos has deployed this solution to using these connectors. And this bank had the challenge of their employees bringing in mobile devices and devices that were issued to employees needed to be authorized to use Wi-Fi networks that were being used within these banks. So how do we do that exactly? Well, a lot of these devices are Windows devices. A lot of them are not native Windows devices or any kind of system that can talk directly to the registration authority. So we use these connectors, AEP and SEA, in order to create that bridge to be able to issue certificates to these devices. So not only is it beneficial from a perspective of bringing all of your devices under one umbrella and being able to manage them there, but also it offers the opportunity of efficiency and easy integration with your information systems. And so it can connect to many different types of devices, like I said, and allows you to manage them more centrally. Next, please. So we talked about a potential replacement for SCEP and how SCEP may be too big for a lot of these devices and SCEP wasn't initially meant for the use in IoT and OT devices. And so how do we really get to that point? Well, in comes EST, which is something that we used in a world-leading manufacturer in the logistics industry. So they have IoT devices that are managed on trains in general, and so these trains are logistics and in the logistics industry, and so in different workflows they use IoT to monitor and do other functions. And so they were trying to secure these communications between these devices and authorize them to use network resources. And so they had a resource constraint that was required for these particular devices, as I said, because these devices are in the field and they may need special considerations for that. So the EST connector uses elliptical curve in order to create its encryption keys. And what that means is this elliptical curve creates a smaller encryption key, smaller encryption size. And so where that resource is so precious and we need to really conserve it, that's somewhere that we can go. But in addition, it's EST is also something that can be used as automatic renewal of certificates. And because the bit rate is, of course, smaller on these certificates as well, in large network devices for corporate infrastructure, it can also be used for certain things. So In general, the automation of this, and then this becomes, and the size of this becomes somewhat of a replacement for the SCEP connectors. Next slide, please. So the Acme connector, in the automotive industry, we had a customer that was looking to avoid critical service interruptions of its web servers. These web servers serviced applications that were in the manufacturing department. And as we know, the availability is one of the most closely related to business functions that we can get with security, whereas confidentiality is something that's more reactive, that we discover that something was exposed and we react to that and so on. But and then integrity as well, like we need to be able to find out that that document or thing has been tampered with. But in general, availability is one of the things in security that happens at the time, right? And we need to be able to respond to that quickly. And to prevent availability issues, uptime is of course important. So how do we do that and manage when we've got many different web services and our availability is something that is so critical to us? Well, the Acme connector provides that capability with connection of these certificates for web servers, right? So to be able to create all of these for web servers without having any availability problems, it needs to be simple, it needs to be fast, and it needs to be native. And so all of these things allow for automation and renewal of these certificates, which means that certificates don't ever expire, and we don't have to worry about the potential for a user trying to access a resource with an expired certificate and getting kicked back with a security issue. And then, of course, because Acme is an open source protocol, it allows for introspection into the security of these things. Next, please. So CMP version 2. Atos had a national telecom operator that was interested in managing gateways of 4G and 5G antennas. And so when we manage these types of devices, this is the stuff that I'm talking about, which is like really remote in some cases and needs to have special considerations for protocols and devices. So it's especially used in the telecommunication industry, but it's something that our solution was able to manage the certificates on these devices. Next, please. And then finally, I mentioned SOAP. So we talked about APIs and how that could potentially utilize the IDCA and RA solution to integrate into whatever you're doing today. And you need digital certificates for something or a project, or you're trying to manage something that's on the cutting edge. This is something that you can connect using APIs that you develop. Next, please. And I'll turn it over to Jerome for this one.
Yes, thank you, Vieri. So as we've seen, there's a lot of rich sets of API and a way to integrate this or to bring trust to the ecosystem. So here, what I'm going to talk about is an actual use case for a large customer we have in North America, which is a defense contractor, around 30,000 people. They started, originally they had a number of systems on premises. They deployed smart card, the fact they do a lot of things with the DoD, USB key, OTP token, and so on. They ended up having 5 or 6 different systems between the credential management, the authentication servers, 2 different flavors of PKI, one Microsoft CA on-prem, another one that was connected to the Federal Bridge. And through acquisitions, they actually get additional systems. So our first challenge with them 4 or 5 years ago was to deploy this cloud-based solution, Axiad Cloud, to address their user authentication challenge, which they did. Now they have one solution that addresses it all. But what we have seen, interestingly, over the past, I would say, 3 years, is increased usage of the solution for non-person entities, to the point that as of now, as of today, I would say around 60 to 70% of the identities managed by the solution are actually machine identities versus user identities. So, it's it started small, but it's growing and it's keeping growing. So some of the use cases have starting using PKI 4 on top of users are VPN. So they have an always on VPN, which implies, on every endpoint, you will have a certificate that authenticates the machine at the time you connect, and then you can establish that it's trusted and, connect to the VPN. They did the same after that on the Wi-Fi access points. So there's the same thing, a certificate so that the Wi-Fi access point can be authenticated by the network and make sure it's trusted and has the right to be there. And also they're doing a big use of PKI for virtual machine infrastructure to sign the VMs and make sure that they have not been corrupted or hacked into, or they can be trusted. And there are quite a few additional use cases that we're looking at together with this customer, and that are enabled by this rich set of APIs that Vieri talks about. So started from the users, but really moved to securing the whole enterprise ecosystem, and we see more and more activities there. From a benefit standpoint for them, because they are a DoD contractor, they fall under this DFARS requirements, what was called the AW171 NIST requirements. So they started, they have been compliant with that over the past few years, and they do an external audit, and that they passed very successfully thanks to the solution, which puts them in a great position, by the way, for CMMC, which is this new government mandate that is coming online that requires third-party audits. So these guys are already doing that. Then, because the PKI is cloud-based, the whole solution is cloud-based, and the fact that we replace 5 different solutions, it really reduced the complexity to manage it and maintain it and patch it, and really free time for their IT team to do more things and look at other aspects of their business. So just a quick summary, and we've got quite a few others, but just this one I think is a good example of how people first started with users authentication, now extending it to looking at the non-person entity. Moving on to the next slide, I think now it's time for questions. So I don't know if we receive, so feel free to put your question on the chat. I see there's already one there, and I think I also received a couple directly to me on the chat. So let's start with the first question. I'll read it, and then I don't know, Vieri, maybe you can start on this one. But it's between different connectors. What are the trends for each one given different business infrastructure environments? Do you see more traction for some? I mean, I think you mentioned SCEP is kind of an older type of implementation. Now there's more demand for newer things. So what do you think are the most important, the one where you see more adoption?
I'm going to answer that one, Jérôme, Axel speaking. So let's make it simple. First of all, just want to focus on the fact that IoT was mentioned a few times during the presentation. Nevertheless, this is also fully available for corporate usage. So IoT here means more generally machines. Okay, it's interesting to know that beyond the fact that we can deliver identities to machines, IoT is also concerned, and IoT can also be covered by the solution, but it's for all kinds of machines. Just wanted to make that very clear at the beginning. Regarding the trends, okay, there are 2 kinds of trends: the usage of the connectors and how we deploy the solution. So regarding how we deploy the solution, you have the cloud-based solution versus on-prem. And today, the trend is clearly going on the cloud-based side. We do see that we have different clients that are switching from on-prem solutions to cloud. And I think that in the coming years, this trend is going to reinforce a little more each time. Regarding the connectors themselves, the clearest trend that we can see, of course, is related to SCEP, as you just mentioned, Jérôme. SCEP is quite old, and when it's been created, it did not anticipate a few things that can make it complicated to have a full lifetime management of the digital certificates. For example, if you use CAPE and you are revoking root authority or sub-CA certificate, well, it can become very complex to manage all the final certificates that will be used by the devices or the machines. And this has been anticipated in the EST protocol, for example. So SCAPE is still used because people know it very well, and it's old, and it can be enough depending on your usage. But today, people will go more to the EST protocol because it will give those benefits that SCAPE is not giving. The other point is that if you use EST, you can cover with only one connector the traditional IT and also the IoT. And if you don't want to manage too many protocols, well, it's quite a good option. So this is for the switch from SCAPE to EST. After this, we have all those connectors because there are different usage on the market, and they are all here to propose solutions that are adapted to specific needs. So as we saw, the Acme protocol is really designed for web server deployment. So you will usually not use Acme for anything else. And if you do not need to cover this need, well, you will not use this kind of connector. Okay. And for CMP, this one is a little different from the others. It has been implemented for the telco industry, as Valerie said. It can be used for other usage, but at the beginning, what it requires is that the devices or machines that will be secured with the CMP protocol will have to share a secret key. And this first step of generating the identities and deliver them to the machine must be very well organized. In the telco world, the whole industry already anticipated this and used the CMP as a common protocol. So you can use the machine from one provider or another. They are all compatible with it. And this is why this industry is liking this protocol. Nevertheless, you could still use another one if you want to. You could use the EST, for example, if you'd like to. But okay, this CMP has been developed for this industry, and it can get extensions for other usage.
Thanks, Axel. I see a couple more questions there, so let's take them in order. From Julie, what do you see as the main challenge for implementation of PKI? I can start an answer on this, and then I'm sure Axel Vieri can add to that. But so it really depends on if you go on-prem or cloud. So for on-prem, the main challenge is finding the right people with the skills to install and maintain PKI. We've seen, as Axel was saying, we see a big trend was a lot of organizations have done on-prem PKI, usually with Microsoft CA because it's free. And then we end up getting involved with these customers because 5-10 years down the road, nobody really knows how to maintain this. It's tough to find the right expertise, in terms of managing the CP, CPS, or the different policies, maintaining and patching the system. So that's one thing, the lack of available resource and knowledge in IT teams to do this properly. If you go the cloud route, the main challenge is going to be around, integrating with these different protocol, and that's where the Axiad Atos team really can help, because we've been doing this for quite a few years, so we can help identify what are the right protocol, the right way to integrate such and such application. Axel, anything you want to add or Vieri on this specific question?
No, this is quite accurate. the task force is quite a big problematic in the PKI management. So as you just said, it will really depend on what you have in your team. Regarding the cloud-based solutions, there would be a challenge, which is to define exactly what you want to do. Because the setup phase is really key to make sure that afterwards, during the run of your project, everything will be fine and correctly defined. Just for example, if you do not define correctly your certificate profile, it can become quite a problem if you start deploying the solution without the right parameters.
Thanks. And then we have one more question, which is good, from Howard. Do you compete in the AWS Azure cloud environments? How do you compete against the Azure CA offering? How does the cost compete, as well as the benefits? Axel, is that one you want to take, or?
I can answer for my part at the technology level. Maybe you want to answer at the service level
Sure.
on your side, Jérôme?
Yep.
Okay, so regarding the technological part, what we provide, in the end, it's still a PKI, okay? So you can use a Microsoft PKI, you can use an Atos PKI. In the end, what you produce is a digital certificate. The difference of our solution is that technically, we will provide those connectors. This is one thing. And regarding the user experience and the way our solution is built, you will be able to generate much more easily very complex workflows to manage the lifecycle of your certificates, which is something that is not included and more complex to build in AWS or Azure CA offerings. So this would be a key point regarding how the solution is built. And after this, you have all the service level that can be provided. Here we are talking about Axiad solution. So I will leave the floor to Jérôme for that part.
Yeah, so I think the main difference there, as Axel was saying, in terms of the richness of the support of different protocol and the flexibility of some of this workflow, AWS does provide a pretty good CA offering, but it's also pretty basic. While I think here we specialize in this space as a team, so that's we have got a lot of expertise there. In terms of our support at the level of service, we are more nimble and flexible organization than AWS, obviously, so we can provide a much closer relationship with the customer. As I think, Howard, we do engage customer quite regularly and have quarterly call and discuss roadmap, and I can provide a higher level of service and integration there. From a pricing standpoint, obviously it really depends of what you're looking for. The pricing approach we have on PKI is based on tiers, so it's not about counting the number of certificates, because that's would be a big overhead. But we define certain level of tiers, and you can have as much as you want within a tier in terms of certs, so you don't need to monitor how many certs you are using at any given time. So we bring a lot of flexibility there. Okay, I don't see. Hold on, let me check on some question was sent to me directly. Yes, there was one around PKI on-prem versus cloud, so we already covered that. Yeah, I think we covered most of the questions. So if there is no more question, and we are actually reaching time, so
maybe we can just add one more thing, Jérôme. It's also that here we made a focus on the lifecycle of machine identity. Nevertheless, all the upper part of one of the slides at the beginning of the presentation also showed that it was possible to deliver any kind of certificates to different supports for people, identity management, and all this with just one solution. And this is also quite a good aspect of it all.
Okay, just to wrap up, and hopefully this was useful for everyone. But we want to thank everyone that participated and attended and asked questions. You've got here our email contact if you want any follow-up discussion or follow-up question. We do have a free proof of concept or demos that you can sign for on our website at axiad.com. Try Axiad. And really our goal, as a joint goal of the Atos Axiad partnership is to bring security and peace of mind to our customer. Our aim is to provide high level of security, but with great ease of use and great service. So, again, thanks a lot for everyone for attending. Vieri, Axel, I don't know if you want to say a few words.
Everything's good on my side.
Okay.
I'd just like to thank everybody for coming today. I appreciate it.
Thanks a lot.
Thank you.
Bye-bye.